In this grade 12 mathematics video, we are looking at the 2025 May-June exam scope. We are going to focus on paper 1 first. We will later do the scope for paper 2 separately. So in this video, we are focusly and strictly looking at the paper 1 scope for the May-June examination that is coming up soon. We are going to go through the scope using last year's past paper, which is the 2024 May-June question paper from the Gauteng province, in order to help us put into context everything that is coming up in the scope. So what I'm going to do is going to be very simple. For every topic of the scope, I'm going to give an exemplary question from the past question paper. That question paper is linked in the description box below. If you go attempt the whole question paper and you have any questions concerning any of the questions, you can leave them for me in the comment section below. Otherwise, let's get into the scope. The first topic on your exam scope is going to be algebraic expressions, and they are going to be found in question 1 of your paper. As I have mentioned before, this is not just going to be us listing the topics that are going to be on your examination. We are actually going to go through some questions. So you're seeing here that we are looking actually at the question 1 of the 2024 question paper. Again, it is linked in the description box below, and we are going to look at what you can expect in the topic of algebraic expression. Obviously, we are looking at questions where you're going to be solving for x, or solving for x and y in a case of simultaneous equations. So how I want to go through this question paper is that with every question, we are going to pick the most juicy question. By the most juicy, I mean the one with the highest marks, and we are going to go do that question together. So here we are looking at 1.3. It says solve for x and y simultaneously, and they have given us a simultaneous equation for 6 marks. So this is the question that we are going to do as your example of what you can expect for the topic of algebraic expressions. So for our simultaneous equation, they gave us the first equation as 3x plus y is equals to 2. The second one is y squared is equals to 2x squared minus 1. So we are going to create the first equation 1 by using the first equation that we were given. The 3x plus y is equals to 2. We are trying to make that a y equation. So that means we're taking the 3x to the other side so that we can be left with a y is equals to, when we get to the other side, we have 2 minus the 3x, because now the 3x was positive, it has gone to the other side. All of this gives us a new equation 1. Then we are going to say that we are going to substitute the equation 1 into the second equation that we were given in our question. So where there was a y, we are now going to put in 2 minus 3x, and because our y was squared, we are going to put the whole thing in bracket and square it at the top, and the whole thing is equals to what was on the other side of the y squared equation, which was 2x squared minus 1. Then we are going to expand our brackets, and we are going to have 2 minus 3x in bracket, and in the second bracket 2 minus 3x in another bracket, and then close the bracket, equals to still 2x squared minus 1, just as it was in our previous equation. Then we are going to solve for the two brackets. So 2 times 2 gives me 4, 2 times 3x gives me minus 6x, minus 3x times 2 gives me minus 6x again, minus 3x times 3x gives me plus 9x squared, equals to still 2x squared minus 1. Then we are going to add the ones that are similar, the similar terms. So 4 minus 12x, where did I get 12x? It's minus 6x minus 6x. Then plus 9 square is equals to 2x square is minus 1. Then we are going to take all the numbers to one side so that we can equate them to 0. So on this side, we are going to have the 9x squared that was already on this side, and then minus the 2x squared that is from the other side. It was a positive, now it's a minus. Then we are going to minus a 12x plus the 4 that was already on this side, and taking the one from the other side, this side, it becomes a plus 1. Everything is equals to 0. Deal with the like terms. Our only like terms there is 9x squared and 2x squared. So 9 minus 2 gives me 7x squared. then we still have a 12 minus 12x because it has no other like terms. 4 and 1 give me a positive 5, and everything is equals to 0. Then from there we are going to use factorization. If you're not familiar with factorization or you still struggle with it, let me know in the comment section below so that we can help you. But either way, when you do factorize, you will be left with 7x minus 5 in the first bracket, and in the second bracket you will be left with x minus 1, and close bracket, everything is still equals to 0. Then we take everything individually out of the bracket. In the first bracket you will have 7x is equals to 5. Then you have to get rid of the x, so you divide both sides by 7. That's why you have 5 over 7. And on the other side you simply have x is equals to 1, and you have solved your algebraic expression. Second topic, still in question 1, is going to be inequalities. Usually inequalities and algebraic expressions are mixed up together, so you will see again in question 1. So again, looking at our question 1, we are looking for inequalities. Inequalities, basically we are saying they are not necessarily equal. That's why you will see that instead of using the equals to sign, we are using the equal, greater than equals to, or less than equals to. So we are again going to look at the most challenging one of these questions, and we are going to solve that one. So we are going to look at the whole 1.2. 1.2 says, given the equation, the square root of x minus 2 is equals to 4 minus x. In 1.2.1 it says, without solving for x, show that the solution lies in the intervals 2 is less than or equals to x is less than equals to 4. So let's solve that. So we are not solving for x. It literally said without solving for x. So we are first going to start with taking out x minus 2 out of a square root. I'm not worried about a square root. I will worry about a square root when I'm solving for x, but this one said without solving for x. So I'm just interested in taking that part and saying that it's greater than or equals to 0. Why? It's not an equality, so I can't equate it to 0. It's simply just greater than or equals to 0. And then I'm going to do the same thing with the other side. The 4 minus x is also greater than or equals to 0. So like I would if I was equating them, I'm simply taking the 2 to the other side. So x is going to now be greater than or equals to positive 2, because when it comes to the other side, it changes a what? It changes a sign. And then I'm going to do the same thing with the 4. But then remember, this 4, when I'm taking it to the other side, is going to now be a minus 4, which means on this side it's leaving a minus x. So now I have a minus x is greater than or equals to minus 4. Then on the other side, I'm pretty much sorted. X is greater than or equals to 2. And on the other side, I need to get rid of that minus next before the x. So what do? I divide both sides by minus 1. Now the only rule that I think that is very important for you to concern yourself with when it comes to inequalities is, when you divide with a negative number, that greater than equals to sign is going to change to less than equals to sign. That's why you are seeing there it says now x is less than or equals to 4. And the conclusion, the only thing that has changed is that the x is in the middle, but x is still greater than or equals to 2 and less than or equals to 4. Moving on to the third topic, we are looking at number patterns. In our 2024 paper, this was in question 2. And of course, as we were doing, we are going to be interested in one that is the biggest question of them all, which is 2.2. In 2.2, we are looking at a quadratic sequence. It says with a general term, Tn has the following properties. T11 is equals to 190, and we have Tn minus 1 is equals to 4n minus 3, where n is greater than or equals to 2. Determine the first term of the quadratic sequence. Now, the reason why a question like this I find it interesting is that we are simply just looking for the first term, but to get the first term you will have to do some work. My prayer for you is that you get excited about juicy questions the way I do, the questions that require the most amount of work. This is where I need you to get comfortable and be where you thrive. So Tn minus Tn minus 1, basically what that tells us is that it gives us the difference. That is the different term. So to solve this question, we are going to use our standard formula. Our standard formula is Tn is equals to an squared plus bn plus c. So this is a standard quadratic equation, except we are doing it in terms of number patterns. So the way the structure is set up, what we are looking for is T1. T1 comes in the first row of our diagram because these are the terms. Like for example, you have T1, T2, T3 up to whatever T. In that instance, you saw that they have a T11, so they can go as far as that. Then when you take T2 and minus T1, that's what our equation is. That's why it said Tn minus Tn minus 1. So for example, if Tn, that n at the bottom was a 2, 2 minus 1 is going to give me a 1. So that basically means the second term minuses the first term. So that's going to give you your first difference. I simply call them the FD1, FD2 and FD3. So that is the line of the first differences. That's why I have put the equation next to it, because that's what our equation gives us. That equation that they gave us is basically going to give us the first difference. When you take FD2 and minus FD1, you are going to get SD1. SD1 is our second difference. So for second difference, I simply use the term SD and then SD1. Usually second differences are going to be the same number. They're going to always be the same number, and I'm showing you this structure because that's how we are going to solve that formula at the top. A is going to be our second difference. That's going to be the same number. B is going to be 3a plus b is equals to the second difference. So we need the second difference and the first difference for us to be able to get the first term. So the first difference, we have said that the equation they have given it to us, it was that Tn minus 1, which is 4n minus 3. So we are basically going, because this is the equation that's going to give us the first differences, that means the numbers that we are going to get when we substitute are going to be the items of our first difference. So we are going to find our FD1, FD2, FD3 and so forth. So how do we do that? They told us in the statement that n is greater than or equals to 2. So that means that the first term, you cannot substitute anything less than a 2 there. So let's start with that one. We'll substitute a 2 and then move on to a 3 and move on to a 4. It's the simplest way to do it. So to get FD1, we substitute a 2 into the equation. So from open bracket, where there was n, we now put 2 minus 3, that gives me 5. To get FD2, I'm going to substitute the n with the 3. That whole equation is going to give me 9. To get FD3, I'll substitute with the 4. Remember, I'm simply counting from 2 going upwards because the statement said n is greater than or equals to 2. So that means my first differences look as follows: 5, 9, 13. You can go as far as you want, but usually if you can get the first 3 terms, that's going to help you get the second difference, and that's about all you need. So how do we get the second difference? So to get SD1, we are simply going to take as FD2 and minus FD1. FD2 is 9, FD1 is 5. So 9 minus 5 is equals to 4. To get SD2, we take SD3 and minus, we take FD3 and minus FD2. So that's 13 minus 9, and it still gives me 4. Like I said, the second differences are always going to be the same amount. So that means my second difference is 4, 4, 4, 4, continuing onwards. So to solve my quadratic equation, remember I said that A is going to come from using second difference. So how do you do that? You simply say 2a is equals to second difference. 2a is equals to 4 because my second difference is 4. Then I divide both sides by 2 for me to be able to be left with a on that side. When I divide both sides by 2, that's going to give me a being equals to 2. That's how we got that. Therefore, a is equals to 2. Then to get b, we're going to say 3ab is equals to 5. By the way, where am I getting all of these things? If you're not aware, these are formulas. It's not things that I came up with. When you study your notes on number patterns, you know that 2a is equals to the second difference, and 3a plus b is equals to the first difference. So 3a plus b is now equals to 5. That's the first term of the first difference, by the way. Not just the first difference, the first term of the first difference. Then where there's a there, using it's 3a, we are going to substitute with a because we now know that a is equals to 2. We did that with the first difference, right? So we say 3 times 2 is plus b is still equals to 5. 3 times 2 is going to give me 6. So 6 plus b is equals to 5. So therefore, we take the 6 to the other side, and when we take the 6 to the other side, I'm left with 5 minus 6. That's going to give me minus 1. So that means my b is minus 1. So we can substitute now into our Tn formula. The a we know is 2, and the b we know is minus 1. So that's why we say 2n squared minus n plus c. To get that c, we are going to substitute one of the terms in our sequence. They gave us term 11. Remember, they told us that term 11 is equals to 190. So we are going to substitute it to that equation, that little equation we had just formulated for ourselves there. Where there's Tn, we put 190, and where there's n, we are going to replace with n11. So 2 open bracket, now 11 squared minus 1 open bracket 11, everything plus c. Then 190, we punch that 2 open bracket 11 into your calculator, is going to give you 242, then plus 11. 1 times 11 is going to give you 11, and then plus c. Take all the numbers to one side so that on this side I'm left with c. So on that side I have 190 minus the 242, because when it goes to that side it will change the sign. The minus 11 becomes a plus 11. Everything is equals to c. So that says to me that c is equals to minus 41. I simply punched everything in my calculator. So therefore, when I put it back into my format, it's going to be now 2n is equals to 2n squared minus n, because minus n and minus 1 is the same thing, right? Then minus 41. So how do I get the first term? I can now use this formula and substitute just 1 into it to get the first term. So where there's n now, I'm going to put 1. So 2 open bracket 1 square minus open bracket 1 close bracket minus 41. Punch the whole thing in your calculator, and your final answer is 4 minus 40. Do you see the amount of work we had to go to just to find the first term of the sequence? And that's what I mean, that these are the juicy questions, the questions that are long. That's why when we did algebraic expressions, the question that I will choose is obviously the simultaneous equations. I need you to be this kind of person. When you look at a question paper, go to the fattest question first. That's how you will know that you have gotten to that point where you are actually enjoying mathematics, and there is nothing that will ever prepare you for an exam than being that kind of person. That when you go through question papers, you're not just looking for question papers for questions that will give you 2 marks. You're looking for questions that will give you a whole 6 marks. So this solves our number patterns. Topic 4 on your scope is functions. With functions, this is the majority of your question paper, so you can expect multiple questions on functions and graphs. From our 2024 question paper, we are choosing to take it from question 5. Again, like I said, there is multiple questions on functions. If you attend them and you get stuck, you have any questions that you need to ask, that's what the comment section is for. Make sure that you leave me a question there. I will give you the explanations that you need to be able to get you off the hooks where you are stuck. So in our question 5.1, it says, the sketch below shows the graph f of x is equals to minus open bracket x minus 2 close bracket square plus 9, and g of x, which is b to the power x, where b is a constant, d is the turning point of f and a point of intersection for f and g. B is the y-intercept, and AC the x-intercept of f. So we are looking at our graph there. We have two graphs, g of x and f of x. And then in 5.1.1 it says determine the length of A to C. So A to C, you see that they are the x-intercepts of the graph of f. What that simply means for you is that we are looking for x-intercepts, and when you're looking for one x-intercepts, you have one golden rule, and that is to equate your y to 0. So what is our y? Our y is the graph of f of x. It says that it is equals to minus open bracket x minus 2 close bracket square plus 9. All of that equation that you're seeing, we need to equate it to 0, or simply turn the f of x into 0, because that is what the y is, right? So we're going to, where there's f of x now, we have simply put 0, and we have now opened bigger brackets because we are trying to expand that x minus 2 that is in bracket because it is squared. So we have now expanded it into two brackets of x minus 2 and x minus 2, and we are going to solve that from within the big bracket, and everything outside the big bracket is still as it is. We have a plus 9. So when we expand in the big bracket, we are saying x times x is going to give me x squared. X times minus 2 is going to give me minus 2x. Minus 2 times x is going to give me minus 2x. And minus 2 multiplied by minus 2 is going to give me a positive 4. Close bracket plus 9. Still 0 equals to minus. We are going to solve what is inside the bracket. The x squared stands as it is. Minus 2 and minus 2 is now going to give me minus 4x plus 4 close bracket. Then plus 9 outside the bracket. Then we take it out of the bracket. To take it out of the bracket, we simply multiply with the minus 1 that is outside the bracket, or the minus that you are seeing outside the bracket. So minus 1 times x squared is going to give me minus x squared. Minus 1 times minus 4x is going to give me positive 4x. Minus 1 times positive 4 is going to give me minus 4 plus the 9 that was outside the bracket. Then 0 is equals to minus x squared plus 4x. The minus 4 plus 9 gives me a positive 5. So then what I'm trying to do here to make things simpler is take everything to this side and take the 0 to the other side. When I do that, is the x is going to change the sign to a minus, from a minus x squared to a positive x squared. The positive 4 is going to now be minus 4x, and the positive 5 is going to be a minus 5. In other words, somebody can say you divided both sides by a minus 1, but that's a story for another day. Either way, so long as you are left with what we have here. Then we are going to factorize again. If you can't figure out how we got that x minus 5 and x plus 1 in bracket from factorizing, that means your factorizing skills are not there. So leave us a comment in the comment section below. Either way, we are left with x minus 5 is equals to 0 and x plus 5 plus 1 is equals to 0. Take the numbers to the other side. I'm left with x equals to 5 and x is equals to minus 1. So to get the length of AC, you simply count with your fingers from minus 1 to 5. Remember, in your counting, you're not including minus 1. You start your counting with 0 up to 5. That's going to give you 6 units. Topic 5 in your scope is going to be differential calculus, and in our question paper from 2024, we are looking at question 8. So for differential calculus, what you can expect is derivatives. So we are seeing there that we have different questions on derivatives. I'm not sure how many or how much of the questions that you're going to have on differential calculus, but I know that some of the questions can be lengthy or they can carry enough marks. Naturally, looking at our past paper, you already know from the mark allocation which question I'm going to choose for us to do together, and that's going to be 8.1 because again, it's the one with the most amount of marks and we love having fun with mathematics in this channel. So 8.1 says determine the derivative of f of x from first principle if f of x is equals to 2 minus 3x squared. So basically here the formula sheet is going to be our friend. We are going to look for our first principle formula, which is, in other words, I like to call it our limit formula. So let's look at it. It says f derivative of x is equals to f of x plus h minus f of x everything all over h. So what we have from our problem is we are given f of x. What we are looking to create for ourselves, for us, before we can use this formula, is that we do not have the f of x plus h. So what we need to do is create the f of x plus h, and that's what you see us doing in the next step. So to do that, we simply take the f of x equation as we are given, but where it says f of x, where there is an x, we replace the x with ax plus h. So starting with the f of x itself, so where we normally had f of x, we now have f open bracket x plus h close bracket. Take the same equation of f of x, which was which was 2 minus 3x, but now instead of just it being x there, we are going to say x plus h close bracket square, and then naturally we need to expand what's in the bracket there. So we are going to say equals to, it's still f of x plus h, but for space purposes we are just simply going to say equals to 2 minus 3 open big bracket. Inside the big bracket we have now expanded the 2x plus h brackets. Then we are going to solve them from our brackets. So 2 minus 3 open bracket x plus x times x is going to give me x squared, x times h is going to give me xh, h times x is going to give me xh, h times h is going to give me h squared. Next step, we solve the like terms in the bracket. So we still have the 2 minus 3 outside the bracket. X squared remains because it has no like term. Then we have 2h, x plus h and x plus h. So when you add them together, they give me 2x plus h, and then we have plus h squared close bracket. Then in the next step, we take everything outside the bracket. The 2 still remains as is for the time being. Then we say minus 3 times x squared is going to give me minus 3x squared. Minus 3 times 2xh is going to give me minus 6xh. Then minus 3 times h squared is going to give me minus 3h squared. Then from there we have what we call our f of x plus h formula. So what we need to do is we now can sub into we can use our f of our derivative formula or our first principle formula. So we are going to simply substitute into it. Substituting shouldn't be a problem at this point of your journey. You're simply writing things as are. So where we have f of x plus h, you are simply going to put 2 minus 3 x squared minus 6xh minus 3h squared. Then you are going to minus and then open a bracket and then put in what is for f of x. Our f of x was 2 minus 3x squared. From there you expand and solve. Like terms will cancel like terms. If you do it correctly, you will be left with f derivative of x is equals to limit h to 0. By the way, in my formula I skipped out the limit h to 0. Make sure that it's in there. Don't skip on it until you get rid of it in the end, right? It's very important that it be in there. So limit h to 0, you will be left with minus 6xh minus 3h squared all over h. The reason you'll be left with this is because you're going to meet a lot of like terms and they will cancel each other, right? And then next step, what you're going to do is you're going to factor out the h from the from the numerator. When you factor out the h, you are left with minus 6x minus 3h, because one of the other h is factored out, all over h. So the h that is on the bottom and on the top are going to cancel each other out. Now you're left with limit minus 6x minus 3h. So now this is where now we use the limit. That's why I was saying make sure that you don't leave out this limit out until you use it. So in that equation that we are left with, our minus 6x minus 3, where there's h, we are now going to substitute the 0. So we put 0 where there's h. So anything minus 3 times 0 is going to give me 0. So that means my f derivative of x by first principle, I'm left with minus 6x. Please do this calculation all in all, especially the part where you need to substitute. Make sure when you substitute and you do it on your own, you are left with that minus 6x plus minus 6xh minus 3h square all over h. If you can't get there and you get stuck, let us know in the comment section below so that we can help you. Otherwise, that concludes our differential calculus question for this paper. So let's look at our scope in totality, or in summary, of what you can really expect for your paper 1 at this examination. We said first, expect that there's going to be algebraic expressions. They are most likely going to be in your question 1, and they are going to be mixed in them with inequalities. The thing about algebraic expressions and inequalities is they can also be integrated into all other questions. You can still solve for x in other questions, like in your differential calculus, in your functions, and so forth, right? And then you have your number patterns. There are different variations this question could come up. Don't forget the sigma notations as well. Then you have your functions and graphs, which I said could be most of your questions. And then you have your differential calculus. Now, it is possible that one more topic could be added to this scope, which is something like your probabilities. I'm not saying that this scope is by any means definitive, but what I am saying is that these 5 topics are going to be the main thing that you need to focus yourself on when it comes to the next coming examination. If you want to make sure that you will master this examination and you want to guarantee your distinction, make sure that whatever you do, these 5 topics you have mastered. Make sure that, because with algebraic expressions and inequalities, we are basically saying that those are going to be your easier kind of questions. That's where you need to double down and make sure that you get those marks to be able to boost you wherever you may struggle. So don't find yourself in a situation where you have concerned yourself with a topic like probability that might be there or might not be there, but the things that you are guaranteed are going to be there, you're not sure or confident about, like your algebraic expressions, your number patterns, and your functions. Make sure that when it comes to these 5, you are absolutely confident and ready for the exam. Now, if you need one-on-one help with anything that we have covered in this video or this subject in general, we have a visual program that can help you with just that. From anywhere in the country, all you need is an email and a WhatsApp, and we are able to give you personalized help for a monthly fee. This will cover full lesson recordings as well as notes and study materials for any of your subjects that you need personal help with. This will include some of the subjects that are not even covered on this channel. For example, subjects like history. You will soon see our full subject list. We will also cover scopes for those specific subjects as well as attempt past papers together. But what's most important about these virtual sessions is that you get full-time communication, meaning from the hours of 8 o'clock to 4 p.m. you are able to send in your questions. Even if you send them at late, between the hours of 8 and 4 you will get replies to your questions. You will get to go back and forth and get full-time attention on any question that you do have. Even if we have to repeat something over and over again, you get to have that personalized help that is helpful to you. As you can see with some of the examples there, we get to exchange scripts, we get to exchange question papers, and you get to show me what it is that you wrote, and you even get markings for your questions to see how you actually do perform when it comes to a specific question or a specific subject. Grade 10 to grade 12, as well as those who are upgrading and rewriting, those are the full list of subjects that we do offer. If you are interested in any of this, for you to be able to get your price quotation, it is very simple. All you have to do is email me on that email address that you see there. When you do email, make sure that in the subject line you write your name and surname, and then in the body of your email, that's where you will tell me your grade and the subjects that you need help with. It can be one subject or it can be a mixture of subject. Hence, we are saying that you need to email for you to be able to get your price quotation. Now, because this is one-on-one, it means that it puts a limit on the number of people I can take per month. So I'm going to be limiting it to 10 students per month. So make sure that you email to secure your spot. Have YouTube recommend you more of my videos, be sure to click the like button and subscribe to the channel. And if you have any questions, leave them in the comment section below.